In this video, I am going to explain about polymers. So first we will discuss synopsis points. So lesson structure. In this chapter we will discuss homopolymers, copolymers, elastomers, fibers, thermosetting and thermoplastics, types of molecular masses of polymers, PDI, polydispersity index, Buna S, Buna N, Decron, neoprene, biodegradable polymers and different types of rubbers and uses. So this is first one definition. The process by which simple molecules are converted into a polymer is known as polymerization. So here poly means many. So poly means many units. Many units. Monomer means single unit. Remember this. Monomer single unit, polymer many unit. Next, examples for cross-linked polymers. Cross-linked. Very important. Cross-linked. That means 3D. Three-dimensional polymers. That is bakelite, urea formaldehyde and melamine. These three examples are very important. Next, examples for addition. Polythene, Buna-N, Buna-S. So, addition polymers are due to unsaturation. Addition polymers are formed due to unsaturation. That means due to multiple bonds. That is double bonds and triple bonds. If monomers contain double or triple bonds, addition polymers will be formed. Next, what about condensation polymers? Condensation polymers are formed due to functional groups. Remember these two words. So condensation is possible in monomers which contain functional groups. Carboxylic acids, amines, alcohols like that. Next. See examples for condensation also given here. Condensation, nylon 66, Decron. Next. Homopolymers and copolymers. Homo means same. So polymers having only one type of monomer units. Examples polythene, PVC, nylon 6 and so on. Copolymers. Polymers having two or more types of monomers. Nylon 66, Buna-N, Buna-S and so on. Elastomers. Polymers in which intermolecular forces are weakest are known as elastomers. So this is possible in case of natural rubber, Buna-S, Buna-N. That means rubbers are elastomers. Next. Fibers. So these are the polymers in which intermolecular forces are strongest due to hydrogen bonding or dipole-dipole interactions. So polyamides and polyesters are fibers. Next, thermoplastics. Thermoplastics means linear or straight branched polymers. Branched means side chains. So which become soft on heating and hard on cooling. Or thermoplastics. Polythene, PVC, Teflon and so on. Thermosetting polymers. These are semi-fluid substances. Low molecular masses. So when heated, so mold undergoes change in chemical composition to give hard substance. That means it becomes hard on heating. Infusible and insoluble masses called thermosetting polymers. Bakelite, urea formaldehyde, melamine. Next, common initiators used in free radical polymerization is benzoyl peroxide. So benzoyl peroxide, very very important. Free radical mechanism. So C6H5 CO OO CO C6H5. Benzoyl peroxide. So this is initiator for free radical polymerization mechanism. Remember this. Next. So types of molecular masses of polymers. So here two types of formula will be there. Number average molecular mass, weight average molecular mass. So number average molecular mass, Mn bar, summation of Ni divided by Ni. So M means molecular mass and N is number of molecules of that molecular weight. Next, weight average molecular mass, weight average, summation of Mi square by summation of Ni Mi. So ratio between these two is polydispersity index. Ratio between weight average molecular mass and number average molecular mass. It is denoted with PDI, weight average by number average. So these are different types of rubbers. Buna S. It is having monomers, that means single units, 1,3-butadiene and styrene. So 1,3-butadiene, we know CH2 double bond CH, CH double bond CH2. This is 1,3-butadiene. Next, styrene. Styrene is vinyl benzene or styrene. So these are monomers. It is used in making automobile tires and footwear. Use is also important. Next, Buna N. It is having monomers 1,3-butadiene common acrylonitrile. Acrylonitrile means vinyl cyanide. Acrylonitrile or vinyl cyanide. Next, it is used in making oil seals and tank linings. Next, Dacron. Dacron. It will be also known as pterylene. Pterylene having monomers ethylene glycol, let formula CH2OH and CH2OH. Ethylene glycol and terephthalic acid. Two COOH groups must be para. Terephthalic acid, TERE. Very very important. These are monomers and their formula. Next, neoprene. So it is having monomers 2-chloro-1,3-butadiene. So 2-chloro-1,3-butadiene. This is 2-chloro-1,3-butadiene. 1,3-butadiene. Next, it is used as insulator in making conveyor belts and printing rollers. Next, biodegradable polymers. That means polymers which contain functional groups similar to the functional groups present in biopolymers and which are degraded in body are biodegradable polymers. So which is best example PHBV. So here poly beta hydroxybutyrate and co beta hydroxyvalerate is known as PHBV. So co means copolymer here, two different types of monomers. So it is specially used in packing orthopedic devices and making outer coverage of capsules. Very very important. Next, nylon 2,6 has caprolactam. Nylon 2,6 has caprolactam and glycine as monomers. Nylon 2,6. Next, these are the monomers. Next, Dacron or tellene has ethylene glycol and terephthalic acid as monomers. So these are biodegradable polymers. Vinyl chloride is monomer of polyvinyl chloride, PVC pipes, Next, tetrafluoroethylene is monomer of Teflon. Teflon is polytetrafluoroethylene. Polytetrafluoroethylene. Next, bakelite has monomers phenol and formaldehyde. Bakelite is polymer of phenol and formaldehyde. Next, so ethylene is monomer of polythene. Next, styrene or vinyl benzene is monomer of polystyrene. So here we have to remember polymers and corresponding monomers also. Next, rubbers. Natural rubber. Cis form of polyisoprene is known as natural rubber. Next, synthetic rubbers. The vulcanized rubber like polymer in which is capable of setting stretch to twice its length and returns to its original size and shape when stretching force is withdrawn is called synthetic rubber. That means stretchable. Next, vulcanization of rubber. That means hardening of soft rubber. The process of heating natural rubber with sulfur at high temperature to improve its properties. Next, Ziegler-Natta catalyst is mixture of triethyl aluminum and titanium tetrachloride. So it is used in making high density polyethylene. Very, very important. High density polyethylene. Ziegler-Natta catalyst. TiCl4 plus Al C2H5 thrice. So next we will discuss worksheet questions. So we will see questions, worksheet questions. So first one, which are the following vinyl derivatives is most reactive towards anionic polymerization? Anionic polymerization. So here it should be Et, ethyl, and here triple bond. So when electron withdrawing group is attached to, that means CH2, CH, C triple bond N, which is electron withdrawing group. So electron withdrawing group is attached to carbon-carbon double bond. It undergoes anionic polymerization. So due to stabilization of anion in propagation, chain propagation. So electron withdrawing groups can favor anionic polymerization. Therefore option D. So which is vinyl cyanide. Next. Second question. So just matching. So here option A is rubber, which is elastomer A2, and B nylon 6, 6 should be there here, 6, 6. Nylon 6, 6. B is 3, which is fiber. Next C 4, Ziegler-Natta catalyst, high density polyethylene. Next about D, melamine formaldehyde, so which is cross-linked. Therefore 2, 3, 4, 1. 2, 3, 4, 1 means here option B should be there. Option B. 2, 3, 4, 1. Next. This is also matching. So natural rubber, that means A, Natural rubber is isoprene monomer. Isoprene is natural rubber. B. Cellulose. Cellulose contains monomer beta D glucose. So here matching is polymer and corresponding monomers. So list 1 polymer and list 2 corresponding monomers. So natural rubber is isoprene. 2-methyl-1,3-butadiene is isoprene, that is monomer of natural rubber. Cellulose contains monomers beta D glucose. Next C. So nylon 6 contains caprolactam, that is 4 caprolactam. Next. So Teflon contains tetrafluoroethylene, that is 3. So 2, 1, 4, 3 is the option. Option A. Polymers and corresponding monomers. Next. So heating of mixture of Cu2O and Cu2S will give Cu2O plus Cu2S gives Cu plus SO2. So this is self reduction. Self or auto reduction. So here copper will be known as blister copper, which is 98% of copper. So this can be purified by Poling process, which gives up to 99.6%. So which on electrolytic refining, it gives copper of almost 99.99%. So very important. So option C. Next. Identify condensation polymer among the following. Condensation polymer. See here. It is the condensation polymer, which is nylon 6. So nylon 6 is polymer of caprolactam, so which is very important compound. Here double bond O and here NH will be there, NH. This is caprolactam. So which on hydrolysis will give, add here OH and here H. So we'll get COOH and CH2, 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 CH2 5 times and NH2. So which on polymerization, if you take N moles, here we will get polymer like this, CO, CH2 5 times, NH, N times. This is nylon 6. So here 6 indicates number of carbon atoms. So homopolymer means the polymer which contains only one type of monomer units. Therefore nylon 6, option C. Remaining are copolymers containing two monomer units, two types of monomer units. Which among the following polymers can be formed by using caprolactam? So now only we have discussed caprolactam. So nylon 6 will be obtained from caprolactam. So here caprolactam is monomer, nylon 6 polymer, and caprolactam is monomer. So option D. So caprolactam is sound number ring with CO and NH. Here NH will be there. NH, which on hydrolysis will give hydrolysis here OH and H, COOH, CH2 5 times NH2. So which on polymerization will give, take n moles CO, CH2 5 times NH, repeating unit N. So which is nylon 6. 6 indicates number of carbon atoms. Therefore D. Next. Which among the following polymers exhibits hydrogen bonding? Hydrogen bonding. So it will be given by nylon 6, 6. Here two monomers are present. Hexamethylene diamine, that is NH2, NH2. Hexamethylene diamine, which contains 6 carbon atoms plus adipic acid, COOH, CH2 4 times COOH, adipic acid. So nylon 6, 6 is polymer of hexamethylene diamine and adipic acid. So which on condensation will give here NH, CH2 6 times, again NH, CO, CH2 4 times, again CO, and so on. So next one more chain will be there. CO, CH2 4 times, again CO, NH, CH2 6 times, NH, and so on. So here hydrogen bonding will be present. Hydrogen bonding. Very, very important. So hydrogen bonding is possible between two linear chains. Therefore option B. So nylon 6, 6 contains hydrogen bond. Next. See here, how many of the following polymers given are condensation polymers? Condensation polymers. Bakelite, nylon 6, Dacron or terylene, melamine. So all these are condensation polymers. Condensation polymers. Due to functional groups. Functional groups are present in these monomers. So therefore answer 4 should be there. 4 means option A. Option A. Answer 4. So very, very important. 4 are condensation polymers. Remaining are addition polymers. Next. In anionic polymerization, the compound which acts as effective chain initiator. So in anionic polymerization, RLI is used as chain initiator. So RLI is R minus plus Li plus. So this can initiate the chain growth. So this compound can initiate. So therefore option D. Alkyl lithium. So this compound is alkyl lithium. Or organometallic compounds. Option D. Next. Observe the following polymers. So among these, biodegradable polymers are biodegradable. That means first PHBV and second nylon 2,6. So these two are biodegradable. That means these can be decomposed by microorganisms. Therefore option B 1 and 2 biodegradable. Next. So Vorlan has unit, monomer unit. So Vorlan means if you take vinyl cyanide or acrylonitrile n moles on polymerization, it will give CH2CH, here Cn, polymer, polyacrylonitrile, so which is known as Orlan. So option D, vinyl cyanide is monomer in Orlan. Next. So which are the following is polyamide. Polyamide. So nylon 6,6 hexamethylene diamine plus adipic acid CH2 4 times COOH. So these two are monomers of nylon 6,6. So it will give CH2 6 times NH CO CH2 4 times again CO and so on. So here amide link is present. Amide linkage. Therefore option A, hexamethylene diamine and adipic acid will give amide linkage. CONH is amide. So which of the following is not biodegradable polymer? So here glyptol, simply glyptol non biodegradable polymer. So it will not be decomposed by organisms, microorganisms. Therefore option A. So remaining are biodegradable polymers. Remaining all are biodegradable. So here one more correction is there. So poly beta hydroxy should be there here. Beta hydroxy. Here poly beta hydroxy. This is nothing but PHBV. So except glyptol, remaining all are biodegradable. Next. So Ziegler-Natta catalyst is used to prepare high density polyethylene. So direct question only. So CH2 double bond CH2, take N times. So at 333 to 343 kelvins and 6 atmospheres pressure. TiCl4 titanium tetrachloride and triethyl aluminum. This is Ziegler-Natta catalyst. It gives CH2 N times high density polyethylene. High density polyethylene. Option C. Next. So cis-1,4 polyisoprene is known as natural rubber. So polyisoprene. Isoprene means CH2 double bond C CH3 CH2. So 2-methyl 1,3-butadiene. This is isoprene. So polymerization of isoprene is polyisoprene, which is known as natural rubber. So here it will be take N moles. Here polymerization will be like this. Here CH3. N units. So polyisoprene, which is natural rubber. Very, very important. So it is 1,4 addition. 1,4 addition. Addition takes place at first and fourth carbons. Therefore, cis-1,4 polyisoprene is natural rubber. Option D. Which of the following monomers can undergo condensation polymerization? So glycine contains functional groups, that is COOH, CH2 and NH2. So this undergoes condensation. So remaining due to the presence of double bonds. So here isoprene contains double bond. Next propene double bond, styrene double bond. Therefore B, C, D can undergo addition polymerization. So glycine due to functional groups, it can undergo condensation polymerization. Next. Which are the following monomers form biodegradable polymers? Biodegradable. See a simple one. See a 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. So these can form PHBV. So poly 3-hydroxybutyrate and hydroxy, that means 3 means here we can take it as beta hydroxy, beta hydroxy valerate. So poly beta hydroxy butyrate and beta hydroxy valerate is PHPV. So PHPV is biodegradable. Biodegradable polymer. So it can be decomposed by organisms. Therefore option D. Next. Which are the following catalysts is used in preparation of high density polyethylene? So simply Ziegler-Natta catalyst. High density polyethylene preparation, Ziegler-Natta catalyst. That means triethyl aluminum plus titanium tetrachloride. Option B simply. High density polyethylene. Next. So which of the following is not example of addition polymer? See here poly is styrene. Styrene contains double bonds. Therefore addition. Next PVC. Polyvinyl chloride. Vinyl chloride contains double bond. Addition. Polypropylene. Propene also contains double bond. Therefore addition. Therefore nylon. Not an addition. So here it should be nylon. Option wrong. Option B. Answer nylon. Nylon 6 and nylon 6, 6, nylon 2, 6, nylon 6, 10. All these are condensation. Nylon. Therefore option B. Condensation. So due to the presence of functional groups. Remaining all can form addition polymers. Next. Here which one is classified as condensation polymer? Condensation. So neoprene addition, Teflon addition, acrylonitrile addition, Dacron. Dacron condensation polymer due to the presence of functional groups. Terylene is also known as Dacron. So it is polymer of ethylene glycol, and terephthalic acid. Terephthalic acid. These are monomers of terylene or Dacron, which is condensation due to the presence of functional groups. Next. So formation of polythene from calcium carbide. Calcium carbide and hydrolysis, acetylene to again ethylene to polythene. This is the sequence. CaC2 plus 2H2O gives CaOH twice plus C2H2. So this is one step. Next C2H2 plus 1 mole of H2 gives C2H4, which is ethylene. Next n moles of C2H4 gives CH2 n times polythene. Next, from this we must calculate amount of polythene obtained. So take here n into what is the weight? C2H4 24 plus 4 28. 28 grams will give n into here C2 H4. So 28 grams. So N cancels here. That means simply 1 mole of C2H4. 1 mole of C2H4 will give 1 mole of polyethylene say. Take here. Here 1 mole will give 1 mole of acetylene. Next 1 mole of acetylene gives 1 mole of ethylene. Next here also you can take 1 mole and here also 1 mole. N cancels here. So therefore CaC2, number of moles of CaC2 equal to number of moles of polyethylene. So CaC2 molecular weight 64. So 64 grams will give, here it is 28 grams. Therefore 64 kg will give 28 kg. 28 is the answer. Option D. Number of moles of CaC2 equal to number of moles of polyethylene. Ethylene molecular weight 28. 64 grams will give 28 grams. Therefore 64 kg will give 28 kg. Next. So this is also matching. So polymers and the corresponding uses. So glyptol is used in paints and lacquers. Option B. Neoprene, rubber, gaskets. Next. Acrylan. Acrylan means to synthetic wool. D. Low density polyethylene. LDP means low density polyethylene. It is used in flexible pipes. See here 3, 4, 2, 1. 3, 4, 2, 1 present in B option. So polymers and the corresponding uses. Next. Caprolactam when heated at high temperature in the presence of water gives nylon 6. We know this. Caprolactam, which is 7 member ring, with double bond O and NH. Switch on hydrolysis will give COOH, CH2 5 times, NH2. Switch on polymerization, CO, CH2 5 times, and NH. This will be the polymer. Nylon 6. Option B. So caprolactam is monomer. Monomer of nylon 6. Nylon 6 is polymer. Very, very important. Option B. Next. Here it is also matching. So option A, nylon 2, 6, which is biodegradable. B, Buna N, rubber, which is synthetic rubber. 3. C, urea formaldehyde, thermosetting. That means C, 1. So D, Dacron. Dacron is polyester. Dacron is polymer of ethylene glycol and terephthalic acid. Therefore 2, 3, 1, 4. 2, 3, 1, 4, option D. Next. So the polymer X contains linear molecules and it is closely packed. Next, it is prepared in the presence of triethyl aluminum and titanium tetrachloride under low pressure. The polymer X is, so simply high density polyethylene. So triethyl aluminum and titanium tetrachloride is Ziegler-Natta catalyst. Ziegler-Natta catalyst, it gives high density polyethylene, HDPE. Option D. Next. So here also matching, important one. So A, 2-chloro-1,3-butadiene, which is chloroprene. Chloroprene means synthetic rubber, A2. B, nylon 2,6, 2,6 is biodegradable, B1. C, polyacrylonitrile, so which is addition polymer, 4. D, Dacron. Dacron is polyester, 3. So 2143. 2143 is present in option D. This is also matching. So weak intermolecular forces, A. Weak intermolecular forces means rubbers, elastomers. Hydrogen bonding, 1. Hexamethylene diamine, that means nylons. Next, heavy branched polymer, C. Heavy branched polymer means C, 4. Phenol formaldehyde, cross-linked polymer, D. High density polymer, it can be prepared by Ziegler-Natta catalyst. 3142. 3142, option B. Next. So which of the following is not a natural polymer? So rayon is not a natural polymer. Rayon is cellulose acetate, which is semi-synthetic polymer. Therefore, option D. Remaining proteins, starch, rubber are natural polymers. Next. So, which of the following sets are correct regarding polymer? So, first copolymer Buna S, which is correct. So, Buna S contains 1,3-butadiene and styrene. Therefore, it is correct. A correct. Next. So, condensation nylon 6,6 condensation polymer due to functional groups. Next. C. Fiber nylon 6,6 due to hydrogen bonding. These are fibers. So, next. Thermosetting polymer terylene. That is wrong. Thermosetting polymers are bakelite, urea formaldehyde, melamine. Next, homopolymer Buna N. Buna N is copolymer. Therefore, clearly A, B, C are correct. Option A. A, B and C are correct. Direct statements. Next. So, which of the following is an example of polyester? So, polyester means here, take option D. Poly beta hydroxybutyrate and co beta hydroxyvalerate, which is PHBV. PHBV. So, which is polyester. Polyester. So, option D. PHBV. Repeating question. Next. This is the end of the chapter. In next video, I will explain one more topic. All the best and thank you.